Hey everyone, today is our first video where we want to guide you on how you can develop your own connector for Google Sheets or BigQuery. And let me walk you through how it works and what you can do with it. So here is the GitHub project for OWOX Data Marts AppScript edition. Imagine you're a data analyst and your colleague, a product manager, a marketer, a finance person, asks you to provide real-time, automatically updated data, and it could be data from Facebook ads, LinkedIn ads, GitHub, HubSpot, or basically any other platform with an open API. You click Import Data and get all metrics in a dedicated sheet with dimensions and metrics. However, once you go to the product page, you might notice that not all of the sources are already available. Actually, there are way more of those already available by the time you are watching this video, but still. And that's okay, there are hundreds or thousands of different data sources available on the market, and we cannot handle that ourselves. In this video, I will show you how to easily develop a new connector from scratch using our template and this guide. Before we start, I'd like to mention everything you need to develop these connectors. First of all, you might need a Google account, definitely, to basically ingest any data into Google Sheets. Let's say we want to ingest data from GitHub into Google Sheets. So today we're going to be developing a connector to the GitHub API. So let's start with the requirements. Besides a Google account, it's great to have a GitHub account too. Basically not because we are building a connector to GitHub to extract the data from GitHub, but because we are going to be posting this connector on GitHub. If you don't have one yet, go ahead and sign up for it. You will need it to join discussions, ask questions, and hopefully publish your own connector when it's ready. And last but not least, you need to have a basic understanding of Google AppScript. That's the language that this connector is built in. We made it Google AppScript, basically JavaScript, not Python, so most data analysts can actually write their own connectors and contribute here. If you don't know it yet, that's totally fine because ChatGPT would help you with that if you need any help. Okay, so imagine we want to build a connector to GitHub API. Let's start by researching the list of available data sources. Maybe someone is already working on this. As you can see, GitHub isn't listed on the main README here. Let's check the discussions. There is no mention of GitHub either. Checking the Issues tab, still nothing. That means that the best thing we can do is to develop our own connector to GitHub data to empower our colleagues that requested this connector and help them build reports using GitHub data. First, we need to figure out what kind of tools we'll use for development. In this video, I will show you how to build a connector using just a browser, so no need for Visual Code Studio or Git on your machine. This approach is easier for most of the data analysts who prefer to use easily accessible tools only, and we'll cover more advanced setups like using code editors in another video. For now, let's start with the essential first step. The first step is to talk with the business user, the owner of the data, or the person who asked for this connector or the data that it retrieves. Ask them a few questions. What kind of a report structure are you looking for? What dimensions and metrics do you need? In my case, let's assume we just need two metrics: number of stars and number of contributors. And we want to get this data on a daily basis. So our connector needs to fetch data from the GitHub API every day, ingest that data into spreadsheet, and use the date field as the unique key to avoid duplicate rows if the connector runs multiple times a day. If we fetch data several times on the same day, we don't want to have the repeated rows, right? So our script should simply update the existing row instead of creating a new one for the same date. Based on my experience, most stakeholders say something like, we are fine with daily updates. But here is the deal. They almost never specify the exact time of the day they expect the data to be ready. So they might be checking the data at 9 a.m., at 12 p.m., at 6 p.m., and if it hasn't been updated yet, you'll get a message. That is why empathy really matters here. So you either go and ask the business user for the exact time he would like the connector to be updating the data, or you go another way. So basically, even if you schedule your connector to run once per day, it might still cause confusion if it doesn't align with the stakeholder's timing, or just the understanding of the timing. If you want to run the connector every hour to be safe, that is totally fine. But then you just must define a unique key to avoid duplicate. So how do we theoretically define that unique key? Well, in this case, we will use the date field of fetching the data from the GitHub API. That's because it's not easy to get the number of stars or contributors for historical dates. GitHub just doesn't provide that directly. And our goal is to run the connector every day, store the data with the current date as the key, and update the same row if the script runs multiple times on the same day. The key idea here is to avoid duplicate rows. So for example, we don't want 5 rows for June 2nd if the script runs 5 times that day. We want one row updated with the most recent values. This means that the data analyst building the connector is in charge of defining the unique key, and in our case, that's the date column. Now, in our GitHub example, we only need one unique key, the date, and that's going to be enough. But in other cases, like we did with Facebook ads, for example, you might need a composite key. For example, a mix of the ad ID, date start, and the date stop. These three fields together make up a unique record. That's what we call a composite key, and you will need to define it clearly in your connector script. Also, here is something important about AppScript scheduling. AppScript lets you schedule scripts to run on an hourly basis, but not at the exact time, like 9:17, for example. So, if your script runs at slightly different times each day, you might still ensure that the logic identifies and updates the same row, not appends a new one every time. So to handle this, you define a unique key, like a date or a composite key. You make sure that the script checks if that row exists, and if it does, update it. If not, just insert a new row. This avoids duplicates and keeps your reports clean. Let me summarize this, because this is very important. So first, talk to your stakeholder and define what metrics and dimensions they might need. Number 2, determine if you need a single or composite unique key. Number 3, make sure that your connector logic updates rows instead of creating duplicates. Number 4, understand the limitations of the Google Apps Script when it comes to scheduling. And number 5, design your logic accordingly to ensure accurate and timely data. That's it. As the next step, we need to check if the GitHub API can provide the data we need, stars and contributors. Instead of reading the full API documentation, I recommend using a tool like Boomerang, which is a Chrome extension, to send requests and inspect responses in a simple interface. It's free and easy to use. But before making any API request, you'll need to create a GitHub Personal Access token. And here is how you do this. Go to your GitHub account settings, Developer Settings, Tokens. Click Generate New Token. Name your token something like OWOX Data Marts GitHub Demo. Set the expiration date, for example, 1 year, and make sure to set 1, otherwise the token may expire unexpectedly. Next, choose the correct scopes and permissions. For this use case, we only need read-only access to the repo to view stats. And finally, generate this token and copy it. This token will allow your AppScript connector to access GitHub data from private or public repositories. Once we created the token, we can send a test request to the API. For example, to check the number of stars, we need to search here the JSON response, and we will see the field called stargazers count. It shows 46 stars here, so let's go and double check it on our GitHub repo. Basically, it's showing 46 as well, so that matches the actual GitHub UI, and we are good to go. For contributors, the GitHub doesn't provide a single contributor count field. Instead, we can get a list of all contributors, and here is the endpoint that is available here in the API response. So we'll need to fetch the list using the endpoint, count the items on the list, and use that count as our contributor metric. In other words, we calculate the value inside the script. Now that we know what data we need and how to get it, let's set up the actual integration. Find the contributors guide on our OWOX Data Marts GitHub repo and scroll to the Creating New Integration section. We now need to use a template from here. There are two folders, as you can see. Number one, the public endpoint, like we have the connector to the Bank of Canada, for example, and the token-based endpoint. We'll use this one for our GitHub connector, since we need to pass the access token here. If you click on the folder, you will basically see two templates inside. A Google Sheet template that acts as a configuration file that you use to set everything up and run the connector, and an app script library that basically handles the logic to fetch and insert data. And it's important here, if you just copy the folder directly in Google Drive, it might create a shortcut instead of actually copying the file. So to avoid this, open each file and go and click File, make a copy, and save it on your Google Drive. So, as I mentioned, this setup is 100% going to happen within Google Sheets and Google Apps Script. No need to install Node.js, Git, or anything else locally. And once you made the copy of the files, you will see the config sheet. Let's tie it up together to suit our new connector. So basically, we need to remove the unnecessary rows from the parameters here and add the ones that we need. For example, the repository name. I'll also place the value right here, OWOX/OWOX Data Marts, and give this parameter a description, name of repository where we fetch data from. We'll later on need to make sure that the connector script reads from this sheet and pulls parameters values correctly. Inside the script, there is a menu with an option called Manage Credentials. By default, the function behind that button, the Manage Credential function, may not exist yet or may not be described yet, so if you click it, you'll get an error. I'll make sure that I add this function to the template after I record this video. But to continue now, let's see how it works. We'll need to authorize the app script to run, but we get an error because this function doesn't exist actually. We can add the access token as one of the parameters to the document. However, this is not secure. I don't recommend you putting the token directly into a spreadsheet cell. Also, please do not hard-code it into the script as a plain string. So instead of this, we'll select a secure way to have full control of who would access token and when. Let's get back to our app script. Let's rename the project name to GitHub Connector Demo. In my case, I have this function already from another integration, and you can also find that in our repository. And again, I will do my best to add it to the template, so when you build the connector, you will see it inside. So what we need to do here is to add a Manage Credentials function to your app script, because this function will securely prompt you to enter and save the GitHub access token. And by doing this, the token will be saved into the document properties, not into the spreadsheet itself, which is much safer, because storing the access token securely is critical. So now we need to connect the right library to implement the extraction function. So here is our library. We have this file from here. It's a copy of a token-based connector. What we need to do is to copy this ID, and we need to explicitly connect it instead of this one. So this library represents the previous library, not the one we are going to develop and change right now. So we need to remove it first and connect the right one. And as I said, the right one is this one. Make a lookup, name it OWOX, and I go with the head version because I want to make sure all the changes implemented the right way. We're almost done. Here is our library. We have standalone libraries, so they include all of the files that are needed to run the integration. Why? Because we want to ensure the security and make everything not just fast, but transparent. In the OWOX Data Mart setup, your app script project includes two core files. One is the connector file. It defines what inputs the user must provide, like in our case, it's the repository name, how to validate those inputs, and how to fetch and transform the data. Here is where we're going to define GitHub pipeline and GitHub connector. Here is our pipeline, here is our connector. Let's rename it here to have the right naming. So let's go with the connector file first. So with our connector, we need first of all to define the required properties that you need to run our integration. In my case, we need to add the GitHub repository name required. Why should that be required? Because without a repository name, we cannot run it. We want to have, basically we can run it, but we want to have a clear warning that something is missing. Let's do it here. And don't forget to remove extra spaces and check formatting, for example, to make sure the repo string has a slash inside. So now let's go over the pipeline file with controls of the data import flow, for example, how often it runs, how errors are handled, how the data is stored, and any customizations around the fetch and ingest steps. By default, the start import process method expects time series data with two arguments, start date and end date. But in our GitHub example, we don't need either of those. GitHub only returns the current state data, not the historical snapshots. So here is what you do. We override this function in your pipeline like this. That's it. This version ignores dates, calls the fetch data function, and saves the returned rows directly into the spreadsheet. You can see the map here in our contributors guide and how all of the functions are connected together. It shows all of the dependencies between them. Last but not least, we need the fetch data function to actually make the call to GitHub's API, process the response, and prepare the rows in our spreadsheet. Now we can run our connector right away, and let's go to the code.js file, agree with all the permissions, and run it. So the sheet is created, but there is no data inside, because our fetch data function basically provides blank data. That's expected for now. So let's go to our ChatGPT suggestions, and here is a way to extract GitHub data using AppScript API, and let me walk you through this integration with my minor changes. So first of all, we would like to use our token, and here is a way to do it. We replace an example script with this structure. Please keep in mind that we need to use this as a property of the access token because the access token itself is an object of a particular parameter. It has a name, description, and we need just a value here. So here we use a repository name from the configuration sheet, and pretty much all we request is 1,000 contributors. Good luck to those of you who already have 1,000 contributors. We don't have it yet. So why do we need to get the list of all of them? Because we'd then be able to calculate the number of contributors, not list all of them. That's the heart of our connector. And last but not least, we need to define a date field, which is our unique key. And why we're going to define it this way? Well, because we want to fetch our data at midnight with no minutes and no seconds. And now we are ready to run our integration. Let's go to our file and run it. So here is our data. And as you can see here, by running import, there is no duplication, no new records here. Assuming this data is going to be for the 1st of June, and by clicking import once again, I'll have the second row ingested. Running once again, I have the same one. No new data was added. And we have all the data here. And by the way, we don't need those rows with start and end dates as well. Let's remove them from the config sheet. And last but not least, let's check it in the most dangerous way. Let's go to the main page of our GitHub repo and do something really weird. I hope none of you would be doing the same, but just for the testing purposes, I'll go and unstar our repo and run the import once again. And yep, here we go. We got it replaced with 47. So by doing that, we have up-to-date information about the stars here. Not start. It's actually a typo here in the naming. Let's rename the property and see how it works. And run it once again. I'll have a new count here. And because it's just extended existing content, not replacing it, not overriding it, we can just go and delete the column that we don't need anymore. We're all set for today. We have all the information, we have all the data ingested into spreadsheets automatically. Now that our import is working manually, let's automate it so it runs daily or hourly. Here's how to set it up in Google Apps Script. So go to Extensions, Apps Script. In the menu, click Triggers. Click Add Trigger. Set the options like which functions to run, import data, deployment head, event source. Then it's time-driven, and I'll go with an hourly trigger. And save it. That's it. Our script will now run automatically, fetch GitHub data, and update the sheet every hour. If you're sharing this with business user, they can run it manually from the custom menu. By setting up the trigger requires them to go through the AppScript interface, which might not be ideal. So usually it's better for a data analyst for you to schedule the connector to run automatically. And we are done for today. Here is what we accomplished. We built a secure token-based connector for GitHub. We figured out how to store the token securely using the best practices. We avoided data duplication with the proper using of the unique key. We automated the import to run on schedule, and we used only Google Sheets and AppScript. No external tools and technology were needed. And we've essentially created a lightweight, free custom data pipeline for ourselves, our team, and our amazing community.